8.4/8.5, proving similar triangles. Today we're going to be learning to apply that similarity to solve. Paths are similar if two things happen. First, we had to have corresponding sides that are proportional. And the second thing we had to have corresponding angles. That are congruent. So in a triangle, that three sides that you would have to chalk are proportional, and just like proving triangles, we have some shortcuts. The first shortcut to prove is AA similarity. If two angles of one are of another triangle, the triangles are similar. If you think of our third angle theorem, technically all three angles are the same. In order to prove it, so let's draw a picture. Here we have triangle ABC, with angle A being 60 degrees and angle B being 70. I also have triangle ZYX, with Z being 60 and X being 50. Now at first look, these two angles are different. 180 minus 60 minus 70, you know that angle is 50. Now I have two angles to say. So I can say that triangle ABC is similar, make sure you're using the correct symbol, to triangle ZYX by AA similarity. The second method is side-side-side similarity. So if corresponding sides of both triangles are proportional, then the triangles are proportional, the triangles are similar. Here, you only have to sides. Again, I'm going to draw a picture. I have triangle MNO with side lengths 2, 5, and 6. And then I have a much larger triangle, DFE, with side lengths 4, 12, and 10. So in order to match up the sides, I'm going to start with the smallest side of each, 2/4. That reduces to 1/2. Then I'm going to go to the second largest side. That would be 5 and 10. That also reduces to 1/2. And finally, I'll check the largest side. 6/12 also reduces to 1/2. It's very important that you match up the sides correctly. Don't just match up 5 and 12 because it looks like they're in the same spot. If it helps to somehow mark your sides, like you matched up 2 and 4, so mark those the same. You matched up 5 and 10. And you matched up 6, and 12. When you name your triangles, here it would be triangle MNO is similar to triangle EFD by side similarity. So look, MN and EF are both marked the same way. I know. Side angle side similarity. If two corresponding sides are proportional and the included angle is congruent, draw a picture of what this would look like. I'm going to have triangle QRS and triangle TUV. Here only two sides are labeled, 3 and 5, 9 and 15, and one angle. It's very important that you remember what it means for something to be the included angle. So the included angle touching both of the sides that are numbered is congruent, and let's compare my sides. 3 over 9 simplifies to 1/3, and then compare my larger sides, 5 over 15, also simplifies to 1/3. Make sure you're naming your triangles correctly. Triangle QRS is similar to triangle TUV by side angle side. Right, go to the back and try some examples. In the first example, we're deciding if the triangles are similar. Please first pause the video, try the examples, and then in letter A, we have two angles marked. If I find my missing angles, they are 69 and 67. I only have one angle, the two angles marked 72. That is not enough information to prove those similar. In B, I have one angle and two sides. Let's check the sides. 6 over 9 simplifies to 2/3. Good. 8 over 12 also simplifies to 2/3. These are similar by side angle side similarity. The last one, I'm going to have to mark some things that I should remember from last semester. First, vertical angles. And also, if I look at my parallel lines and my transversal, I should notice alternate interior angles. Here, I have two angles the same. I might not know exactly how big they are, but I do know that they are congruent. So pause the video. Of these three triangles, you have to decide which are similar. So let's number them. 1, 2, and 3. Notice all sides are labeled, so we're going to be using side similarity. Let's start with the triangles 1 and 3. First, I'm going to compare the smallest side to the smallest side. So that would be 6 over 3, which simplifies to 2 over 1. Now let's check my middle side. 15 and 5. That simplifies to 3 over 1. since those ratios are not the same, those are not similar. Now, let's check 2 and 3. Again, my smallest side is 3, my biggest side is 10. That does not simplify. My middle side is 5, my next biggest side is 25. That simplifies to 1/5. The sides are not proportional, so they are not similar. Finally, let's try triangles 1 and 3. My smallest sides are 6 and 10, which simplifies to 3/5. My middle sides are 25 and 15. Sorry, 15 and 25, which also simplifies to 3/5. And my largest is 18 over 30, which simplifies to 3/5. So I can say that triangles 1 and 3 are similar, and I'm going to name them. Triangle LKM similar to triangle RQS are side similarity. If you put L second, R should be okay. Finally, the last one, using those proportions to solve problems. Pause the video, try the example, and then check your answer. If it helps for A, I'm going to draw my 2 triangles separate. The smaller triangle here and the larger triangle. I'll label the sides that I know. Now I'm going to use a proportion. 4 and 9 are in the same spot, so is 6 and x. Notice 4 and 6, since they came from the same are both on top. I can cross multiply. 54 is 4x, and divide both sides by 4 to get 13.5 for x. I'm going to do the same thing with b. 3 and 9 correspond because they're both in between the right angle and the marked angle. That's one side of my proportion. 5 and x also match up. They're touching the one angle and the one angle. Again, cross multiply. 45 is 3x. Divide both sides by 3, and I get 15 equals x. If you weren't sure, these triangles are similar because they both have 2 angles marked the same. And in A, these triangles are similar because the top angle matches and the corresponding angles match. So both of them were similar by AA similarity, which is why we could write